This procedure can help answer key questions in the functional oxide community, such as how chemical and physical disorder directly affect long-range magnetism. The main advantage of this technique is that it allows for a large degree of tunability in the material chemistry and can be applied to a variety of ESO compositions.
Demonstrating the procedure is Peter Meisenheimer, a graduate student in my lab.
First, grind the required oxide powders and use a die press to compress the powder into a pellet to form the target. Sinter the target in air at 1100 degrees Celsius for 24 hours. Then, while still at 1100 degrees Celsius, remove the crucible containing the target from the furnace. Use tongs to place the target on the same heat-tolerant surface. Wait for the target to stop glowing and quickly quench the target in room-temperature water. When the target is no longer sputtering, remove the target from the water and set it aside to air dry. Once the target is cool and dry, calculate the target density and the percent theoretical density. If the measured density is insufficient for pulsed laser deposition, regrind and resinter the target. Prepare additional targets in this way as desired. Polish each target in a circular motion using progressively finer grits of silicon carbide paper until the surface is reflective and uniform. Store the polished targets in a desiccator until ready to begin the pulsed laser deposition procedure. Ensure that a 248 nanometer krypton fluoride pulsed excimer laser with a pulse width